Hello and welcome to our first video on probability. I'm Mr. Chowdhury and today we're going to be looking at what is probability. Now this lesson is going to be focused around giving you an idea, a very basic idea of what probability is before we delve a little deeper into working specifically with probability. So before you watch this video, I suggest you make sure that you are confident in converting fractions, decimals and percentages. Now if you're already at that stage and you feel confident with converting between fractions, decimals and percentages, let's start with today's lesson. Now, what is probability? What is probability? Probability is a sentence starter that I've given you. What I'd like you to do is pause the video and try and give a definition for what probability is. And then I'll give you my definition. So if you want to pause the video and do that. Okay, so probability can be defined as the following. The chance of an event happening, how likely an event is to occur. Now, in this definition, we can see a new keyword that you may not have come across before, and that keyword is event. An event is one or more observational outcomes. So one or more observational outcomes. So for example, rolling a 6 on a dice is an event. For example, it raining on a Tuesday is an event. So these are all examples of events. Now here's something I'd like you to do. So this is your first task. Your task is to place the following words on this number line. Now you may have seen this in primary school or whenever you first encountered probability in your mathematics education. So all I'd like you to do is place these words on this number line. That's all you need to do. Pause the video, have a go at that, and I'll come back with the answer in a second. Okay, so let's go through the answers. So on this left-hand end point, we're going to put impossible. We're going to then put unlikely as the next rung up on our timeline. Then we've got even in the middle, likely on the second to last from the second to last from the right, and certain on the very right. That's how we would have done this. So impossible on the very left, certain on the very right, and then even in the middle. Now, we're going to be working with this number line for a second now. We're going to be working on the next couple of minutes. We're going to be working on this. The two things I want to get rid of is unlikely and certain. And the reason I want to get rid of those is because as words, they are very subjective. As words, they are very subjective. So it very much depends on a variety of factors whether something is likely or unlikely. It depends what your position is and what things are going to happen and what you're looking at in terms of the probability, which means that in mathematics that becomes very vague, and we don't want to be vague. We want to be as precise as possible. So for this particular lesson, we're just going to get rid of those words unlikely and likely, and we're just going to work with these three factors because they are significantly easier to measure, therefore we can be very accurate with them. And these are impossible, even and certain. And by the end of the lesson, you won't need to use the words likely or unlikely anymore. You can use them as a way of explaining something to someone later on, but we're going to be concentrating on being more accurate. So here's what I'd like you to do. Here are some events. What I would like you to do is place them where you think they belong on this number line. Now, when I do go through the answers, as the event goes to its correct position, it will then disappear. The reason it will disappear is so that we have more space to move the other events around without you getting confused and the words overlapping. So just be aware of that when we go through the answers. So once again, I'll remind you of your task. Place these events where you think they should go on the number line. Pause the video and have a go at that, please. Okay, so let's have a look at these answers. So finding a pot of gold at the end of a rainbow is pretty much impossible. You're probably not going to find it. It's not a complete impossibility, but for this exercise, we're going to say it is an impossibility. The next one, getting heads on a coin. Well, that's an even chance because you can either get a head or a tail. We're not going to consider the coin landing directly on its side. Don't worry about that. That will just make life significantly harder, and we don't need to consider that right now. The next one is taking a breath in the next minute. Chances are you're definitely going to take a breath in the next minute, unless you decide to hold your breath, which I don't recommend you do right now as you're trying to improve your maths. And your last one, rolling a 7 on a dice, is impossible, because we know a dice only has numbers between 1 and 6. We cannot roll a 7. So hopefully that's been pretty interesting for you. That was pretty easy for you. So here's the next task that I'd like you to do. So remember, we were talking about being a bit more accurate. And the way we're going to be a bit more accurate is by using values. So right now we've been using words: impossible, even, certain, likely, unlikely if you wanted to. But that's what we're going to be a bit more accurate, and we're going to use values. We are going to assign numbers to these words. So what I would like you to do is, here are a selection of numbers. They're fractions, there's percentages, there's decimals, there's an assortment of numbers here. What I would like you to do is put them where you think they belong on this number line. So you're going to put these numbers where you think they belong on the number line. This time they will not disappear, they will stay. So have a go at that, and I'll come back in a couple of seconds. For you, it could be a minute, however long. Just pause the video, have a go at that, please. Okay, so let's go through the answers. So we're going to start off with 0. 0 is impossible. If something has a 0 chance of happening, it's impossible. 1 is certain. If something has a 1 chance of happening, it's definitely going to happen. It's certain. 0.5 would then be even, because we know if impossible is 0 and certain is 1, halfway between them, an even chance would be 0.5. Now let's look at some of the percentages. So we've got 50%, which is even, makes sense. 100% is certain, which makes sense, because if 50% is even, a 50% chance of something happening. We've said this a lot, you've probably heard that a lot. 100% will definitely be certain. If 100% you're going to do something, 100% you're definitely going to do it. So that's definitely certain. And the last one is 0%, which is impossible. 0% chance of something happening, it will never happen. And the last one would be 6 out of 6. So if I've got 6 out of 6 or 6/6, there's a fraction, that's certain. That's definitely going to happen. 0 out of 5 is impossible, and obviously a half is even. Now, hopefully you were able to do this, and the key thing to take away from this particular task is that we can represent probabilities as decimals, fractions, and percentages. So that's the key thing to take away. That's the key thing you should have taken away from doing this task. We can represent decimals, fractions, and percentages. They are representations of probability. So just to recap very quickly before we move on: 0 is impossible, 1 is certain, 0.5 is even, 0 again is impossible, 100% is certain, and 50% is even. The key thing to take away from this, because this would just be 0. 0 out of 5 is just 0, and 6 out of 6 is just 1, so that hasn't changed. But a half is even, so they're the key ones you need to remember. Impossible, even, certain. They are the key ones. So we're going to do a little bit of a game now, just a little bit of a practice. We've done this a lot in previous videos, so we can do it again. So what is the probability of the blue counters? What is the probability of the blue counters? Pause the video, have a think, and then I'll go through the answers. Okay, so let's have a look. I've got 1, 2, 3 blue counters out of 1, 2, 3, 4, 5. So that's 3 out of 5. Now I can write that as a fraction, which is 3/5, which I can very quickly convert to a decimal, which is 0.6. Now I did this in my head, but if you want to use a calculator, that is fine. Currently in this lesson, we are not looking at your ability to convert between fractions, decimals, or percentages. We're looking at your ability to find probabilities and know what they are. And the last one is 60%, because I can convert 0.6 to 60%. So here's your next question. This time I'd like you to give it to me in words, as a fraction, a decimal, and a percentage, please. Pause the video, have a go. Okay, so let's have a look at this one. I've got 1, 2, 3, 4 blue counters out of 1, 2, 3, 4, 5, 6 counters total. 4 out of 6, which is 4/6, which is 0.6 recurring, which is 66.6%. Now the key thing to take away from this one, which is very important, if we look at 4/6, this is a fraction we can simplify. I have not simplified this for the following reason. Right, I haven't simplified this because it's a much better representation to say that there are 4 out of 6. If I wrote 1 out of 3, although it's exactly the same, the probability has not changed. It's more difficult for you to look at that fraction and say, how many counters were there to begin with? Whereas this one, we know there are 6 counters and 4 of them are blue. Right? Makes sense. So the key thing to take away from this slide is when we're working with probability, we do not need to simplify fractions at all. This is the only time I will ever say to you, you don't need to simplify fractions. The only time we don't simplify fractions is when we're working with probability. You don't need to. If you want to, that's fine, but you don't need to do that. It's not a necessity to simplify a fraction. Any other time you're working with fractions, you will always simplify them. Okay, let's have a look at another one. This time I'll go through the answers a bit quicker. So pause the video, have a go. What's the probability of picking a blue counter, please? Okay, so this one is 3 out of 6, which is 3/6, which is 0.5 or 50%, or we could say evens. It's an even chance of happening. A blue counter is an even chance of getting a blue counter. Right, this one, please, pause the video, have a think. What's the probability of picking a blue counter? Okay, let's have a look at the answers. 6 out of 6, which is 6 out of 6 as a fraction, 6/6, which is 1 or 100%. You are definitely going to pick a blue counter in this question because all of the counters are blue. Okay, let's start looking at our last one. Here it is. What's the probability of picking a blue counter? Pause the video, have a think. Okay, let's have a look. So that's 0 out of 6. None of the counters so far are blue, which is 0/6 as a fraction, 0 as a decimal, and 0% as a percentage. So we can see that because there are no blue counters, it is impossible for us to pick a blue counter. So now let's have a look at this one. This is not a question, we're just going to go through it together. Not a question, we're going to go through it together. So if we have a look, I've got 1, 2, 3, 4, 5, 6 blue counters and 1, 2, 3, 4 yellow counters. That means I've got 6 out of 10 blue counters and 4 out of 10 yellow counters. So I can say the probability of picking a blue counter is 6/10 or 0.6 or 60%. And I can also say the probability of picking a yellow counter is 4/10, 0.4 or 40%. Now let's have a look at what we can see if we look and compare these fractions, the decimals and the percentages together. I can see that 6/10 plus 4/10 gives me 1 as an answer. I can also see that 0.6 plus 0.4 gives me 1 as an answer. And I can also see that 60 plus 40 gives me 100 as an answer. And that's really important because this is another thing that you need to know about probabilities that you probably knew intuitively, but I'm going to give it to you as an actual fact that you need to know. You need to know the following thing. Probabilities of mutually exclusive events sum to 1 or 100%. So they'll sum to 1 or 100%. So if you're working in fractions and decimals, they will sum to 1. And if you're working in percentages, they'll sum to 100. Now, we've got another key word here that you may not have seen, which was mutually exclusive. Well, what does mutually exclusive mean? Well, mutually exclusive is a mathematical way of saying that events that cannot happen at the same time. So, for example, it's impossible to get a head and a tail on a coin at the same time. So those events are mutually exclusive. It's impossible to roll a 3 and a 6 on a dice at the same time. The event of getting a 6 and the event of getting a 3 on a dice are mutually exclusive. Mutually exclusive events cannot happen at the same time. Now, before we round off this video, just to give you some key points to take away from this video. The key things to take away from this video are as follows. An event is one or more observations or outcomes. That's what an event is. Probabilities can be written as fractions, decimals, and percentages. When working with probabilities, we do not need to simplify the fractions. Mutually exclusive events are events which cannot happen at the same time, and mutually exclusive events sum to 1 or 100. They are the key points from this video. If you would like, you can screen grab this, so just print screen it now very quickly. You can write it down on some paper so you have it with you. or you can always come back to this video and watch this again just to give you a reminder. But these are the key points to take away from this lesson. These are the key things to understand about what probability is. Hopefully this has been useful. If you're feeling confident, you can go and watch Mr. Amoson's videos and practice some questions. If you're feeling super confident, you can go on Dr. Frost and Corbett Maths to do some more practice. Hopefully you can go off and be productive. I will see you in the next video.